A very good evening, dear students. Today I am going to present a lecture on the paper that you have in the sixth semester, that is Electrical and Hybrid Vehicle, with the paper code PEEE 602A. So, we are going to discuss a part of Unit 1, that is Introduction. Myself, Dr. Rajashree Dhua, Assistant Professor, EEE Department, and I will be sharing this lecture with you. So, as we have already discussed about the concept of hybrid electric powertrain or drivetrain, where there are two powertrains, one is unidirectional in nature and the other is bidirectional in nature. Now, we are going to explain it in details. Now, this is a configuration of a series hybrid electric drivetrain having electrical coupling. So, what this figure basically says, so this is the fuel tank and this is the IC engine. We have shown a power speed characteristics of the IC engine. From there, there's a generator, then there's a rectifier, then there's a motor controller, and this is the traction motor with its ideal torque speed characteristics like this. In the low speed range, it's constant, then it is hyperbolically decreasing. From there, via mechanical transmission, we are releasing the power to the drive wheels. And whatever tractive effort that is shown by this graph, that is the tractive effort versus vehicle speed. After that, we have a bidirectional DC to DC converter, which is attached to the battery pack, and also we have a battery charger that can be externally charged also. So this particular rectifier and the DC to DC converter block is basically known as the electrical coupler. Now, how this particular configuration of a series hybrid drivetrain is explained? So, basically, a series hybrid drivetrain is a drivetrain where there are two electrical power sources feeding a single electrical power plant. Here, the electrical power plant is the electric motor or the traction motor that helps in propelling the vehicle. And this configuration is the most commonly used, as we have already seen in this figure. Now, the unidirectional energy source, as I've already mentioned, is the fuel tank and the IC engine because this particular thing is only needed for traction. As you can see that this bold arrow is the traction and this dotted arrow is the battery charging phase. So the unidirectional energy source is the fuel tank and the unidirectional energy converter, that is the IC engine, and it is coupled to an electric generator. The output of the electric generator is connected to the power DC bus through a convertible electronic converter. That is the rectifier in this case. So this one is the rectifier. Now, the bidirectional energy source will be the battery pack that is connected to the DC bus by means of a controllable bidirectional power electronic converter, that is DC to DC converter. Now, the power source 2 or the powertrain 2 is always bidirectional in nature because the traction motor acts as a generator and it recharges the battery through the process of regenerative braking. So that's why the bidirectional power electronic converter is used. The power bus is also connected to the controller of an electric motor, and the traction motor can be controlled either as a motor or a generator and in the forward direction or in the reverse direction for the process of regenerative braking. And also the drivetrain might need an external battery charger to charge the batteries by a wall plug-in from a power grid. So the batteries can get charged externally also. And the series hybrid drivetrain basically came originally from the concept of a particular battery electric vehicle, that is the EV, on which we are adding the additional engine generator set to extend the operating range because the poor energy density of the battery limits the operating range. So the hybrid drivetrain or the series hybrid electric vehicle basically came into existence because of the disadvantages of the sole battery powered electric vehicle. Also, the drivetrain will obviously need a vehicle controller to control the operation and the power flows based on the driver's command through the accelerator and the brake pedals, and several other feedback information is also needed. So those things are actually not explicitly shown in this block diagram because it increases the complexity of the system. And the vehicle controller will control the IC engine through the electrical coupler. What is the electrical coupler? As we have already mentioned, the electrical coupler is a rectifier and the bidirectional DC to DC converter set, and the traction motor to produce the demanded propelling torque or the regenerative braking torque. Now, what are the different modes of operation that this particular series hybrid drivetrain can operate with? So, that is basically given in the next slide. So, what is the different modes of operation? The first one is termed as the pure electric traction mode. In this mode, as we can see from the name, the vehicle receives its propelling torque or the tractive torque only from the batteries and not from the engine. So here the IC engine is not coming into play. So it is known as the pure electric traction mode. Second operating mode is the pure engine traction mode. Here the vehicle traction power comes only from the IC engine generator set, while the batteries are neither supplying power nor accepting any power from the drivetrain. The electric machines serve as the electric transmission from the engine to the drive wheels. The third is the desired mode, that is the hybrid traction mode. Here the traction motor draws its power both from the engine generator set as well as the batteries, which are merging together in the electrical coupler, that is the rectifier and the DC to DC converter set. Now, fourth mode of operation is the engine traction with battery charging mode. Here, what happens? The engine generator supplies the power to charge the batteries, and it also supplies the power simultaneously to propel the vehicle. And the engine generator power is split in the electric coupler. So, what happens is that a part of the engine generator power, it comes to recharge the batteries, and the part it goes into the serving the tractive power or the traction power to the motor. Now, the fifth mode, it is the regenerative braking mode. The engine generator set is now turned off and the traction motor is operated as a generator powered by the vehicle's kinetic energy or potential energy. And the power that this motor, now acting as a generator, develops, the power generated is used to charge the batteries, and the batteries can later use this power to propel the vehicle. Number six is the pure battery charging mode. Here, the traction motor does not receive any power, and the engine generator is only operated in order to charge the batteries. And the seventh operating mode is the hybrid battery charging mode. In this mode, what happens? Both the engine generator and the traction motor, now acting as a generator, operates in the braking mode to charge the batteries. So the batteries are receiving the energy from the ICNG generator set as well as the energy during the regenerative braking. So both the traction motor and the ICNG generator set, they are simultaneously working in the hybrid mode to charge the batteries. So these are basically the seven modes of operation, that is the pure electric traction mode, the pure engine traction mode, the hybrid traction mode, the engine traction with battery charging, regenerative braking mode, and the pure battery charging mode, and the hybrid battery charging mode. So these are the seven modes of operation that the series hybrid drivetrain can work with, and which mode of operation we will choose, that will be basically controlled by the uh, driver who is driving the vehicle, and the signal is produced or transmitted through the motor controller. So this is one of the important topics of the working modes of a series hybrid drivetrain and its detailed operating conditions.